Hello, everyone. On behalf of Armada Security LLC, I'd like to welcome you today to the presentation about securing cloud assets of Design World Incorporated. Today's presenters will be myself, Prashant Sapkoda, Michael Torres, Marcus Knoll, Andrew White, and Michael Baker in that particular order. For today's agenda, we'll start with a brief introduction of Design World. After that, we'll talk about its system environment. Then we'll move on to pre and post hardening vulnerability assessment, what we did and what the results we obtained. And similarly, we'll talk about the pre and post hardening penetration test and the results we got. That will be followed by the project change request we submitted. Then we'll talk about the security hardening steps we took and the post-hardening assessment we got after running the post-hardening penetration test. We'll then delve deeper into system security plan that we developed and submitted. And finally, we'll talk about lessons learned, what we learned after completing this project. All right, let's start with the introduction. The Design World is a multinational company, engineering and design firm. It's located in 3 different continents: North America here in San Diego, Asia, for Asia location, it's in Hong Kong, and for European location, it's in Brussels. It has around 100 employees. It specializes in the design of artistic structural support systems. It has been a recent victim of targeted attacks, both physical break-in and hacking of remote resources, remote designer systems. This is the reason why all operations are now moved to cloud and everyone is working remotely using virtual private network and virtual machines. The Design World system environment, it is comprised of web services and business services on 2 different subnets. So the web services are hosted on CentOS servers, and the business services are hosted on Windows and Ubuntu servers. For the access to its cloud environment, a user will have to use a 40 token generator, username and password through the VPN, and will finally get access to the cloud, and everything is done in cloud and it's stored in cloud, so no one can actually, this is actually working as a data leak prevention DLP solution. From here, I will pass it to Michael Torres, and he will be talking about pre and post hardening vulnerability assessment. Michael.
Yes, hello, as Prashant mentioned, my name is Michael Torres. I'll be presenting on our vulnerability assessment, both before and after hardening the systems. So specifically, this slide is the pre-hardening vulnerability assessment. For both tests, we elected to use the Nmap network enumeration tool to confirm that the network was actually deployed as was depicted in those network diagrams that Prashant showed. From there, we used Nessus to identify known vulnerabilities on the target network. These 2 tools were selected for 2 main qualities. First, they're free. Free is just about the best cost you can get, and because they are effectively the industry standard way to conduct vulnerability assessments. Before hardening the system, as shown in these tables, we found a fairly large number of vulnerabilities in both the business and web services subnets. This corresponded to an overall assessed risk level of very high due to the likelihood being possible, meaning that it is likely to occur, and the maximum severity being intolerable, meaning that it would effectively result in the shuttering of the Design World business. In the post-hardening assessment, we used those same tools over again. So Nmap and Nessus, using the same techniques, the same types of scans so that our results were consistent. As you can see in these tables, we were able to reduce both the quantity and the severity of vulnerabilities present pretty much across the board. This reduced the expected severity of a risk event to tolerable. You will note that there are some critical and high severity vulnerabilities still present in the network. This was due to unforeseen technical difficulties while we were hardening the devices, but we did include remediation plans for that in the system security plan, which we'll talk about later. Because the expected severity was reduced to tolerable, the overall risk assessed was medium. Up next, we'll have Michael Baker, sorry, not Michael Baker, Marcus, talking about the penetration testing.
Thank you, Marcus Torres. Like Michael said, my name is Marcus Noel, and then I will be talking about the pre and post hardening penetration test. And for that, we use a number of exploitation. And then one of the exploitation that we use Pudo, which is padding Oracle on the downgraded legacy. And we use that to target Windows 10 workstation. And then we also use SSH server cipher blockchaining, CBC. And then we use that to attack the CentOS workstation. We also use SSL, which is medium strength cipher suite. We use that to attack the Ubuntu workstation, and then we also use SSH password logging enable, and then we use that for the web servers, also Apache, Tomcat, and also for the penetration test, we also use a number of tools. For example, you use Metasploit framework, and we also use Nmap. We also use Secure Shell and SCP. Now I will pass to Andrew White that will be talking about the project change request.
All right, thanks, Marcus. So for the project change request, we really wanted to keep this for the customer as non-technical as possible. We wanted to keep it simple. We hadn't built a PCR up to this point. So when one was presented to us, we really felt that it resembled POAM pretty well. So that's the format that we went with. We did prioritize only the critical and high severities, knowing that those were going to immediately reduce the risk to the system, leaving the mediums and lows to fall off when most of those were remediated. And again, our aim for the PCR with the time frame we were given was to make it manageable in the time frame we were given. We wanted to get as much done for the customer that's going to reduce the most risk in the time given without leaving too much after. So that was our aim for the reason we made it the length that we did. For the system hardening, we used the CIS controls, so the Critical Security Control Framework from the SANS Institute. We felt that was, again, given the time frame, with being able to map both of those to the NIST 171 and the ISO 2700 series or 27,000 series, that was per the customer statement of work. We felt that focusing on one framework and the time frame given was going to give us the best results. And we did see a majority of our remediations, we did actually reduce 87% of the vulnerabilities for the system. And it lowered it from that very high initially on the pre-assessments to a medium afterwards. And then anything that we weren't able to accomplish in that time, we did go ahead and just push that to the POAM on the SSP plan. And for that, we're going to push to Michael Baker to speak to that.
All right, thank you, Andrew. I'm Michael Baker, and with our System Security Plan, or SSP, the biggest thing that we try to impart to the customer is that this is a living document and it's designed to adapt to the shifting security landscape. Specifically, cybersecurity is an iterative process. There is no such thing as a 100% hardened system. The system security plan is designed to continue to address security concerns and implement fixes that may not have been present, or to identify policies that will continue to secure the network. For our SSP, we included 7 policies, which included the acceptable use policy, access control, and password policy, a policy for bring your own device, change management policy, a cloud computing and data classification policy, and remote access policy. In addition to the policies, there is also, we use the SSP to also implement STIGs, which were something that we wanted to execute through our hardening, but due to some failures on the hardware or our access to the network, we did not have enough time to accomplish this. So we thought that the SSP was an ideal location to identify those further follow-on hardening steps that could be done in the next iteration of securing the network. And in the next and last slide, we will be talking about the lessons we learned. 2 of the biggest takeaways that we got from this process with providing guidance to Design World was that in executing our penetration test, it would have been ideal, or a better practice would have been to be more precise in identifying the targets we actually wanted to exploit when executing on the penetration test. We did identify potential vulnerabilities based off of the vulnerability assessment that we conducted, but we didn't take into consideration fully the all of the security that was in place, some partially from the OS, and also some of the vulnerabilities would have required us to create data or create an environment to allow the vulnerability to actually be exploited. And that wouldn't have been organic or really proven anything, because it would be us playing both sides, whereas we wanted our penetration test to show what someone on the outside could do without modifying or tampering with the system. And then in addition to that, while we did start our assessment and this process to provide guidance to our customer by assessing the network, it would have been a good idea if we would have gone back and done another assessment and scanned the network and made sure we were comfortable with the environment after realizing that there was a hardware failure. That would have saved us some time. We would have identified some of the concerns that stopped us from continuing with our hardening, and it would have been just an overall benefit and made us more efficient. So those were the 2 biggest takeaways I think we had. And with that, we can conclude our presentation. And at this time, if there are any questions, we would be willing to take them.